Hello and welcome. I hope you all are doing well today, staying safe wherever you're joining me from. I'll get started in just a moment. This session is all about blockchain oracles. So I'll just begin with a little bit of an overview of what we're going to cover. We're first going to build a shared understanding of oracles and what they are. I'll cover the different types of oracles, why they exist, some challenges that we need to consider when using oracles, and then I'll introduce some solutions available to actually implement and go out and build your own oracle solutions. And then we'll focus on one of those solutions to use for a demo. So this session does assume that you know the basic fundamentals of blockchain. I won't get into any of that. We are going to be using Solidity and Remix. Those are kind of my handy tools that I spend a lot of time exploring. So we're going to get more hands-on experience with those, creating smart contracts that use oracles. I am monitoring the chat over to my side, so if you have any questions, please pop in there, say hello, let me know how things are going, and yeah, I think that's about it. So let's jump right on into things with what are oracles. So a blockchain oracle is a third-party source on your blockchain network that is trusted. An oracle sends information to your blockchain and executes the conditions that are programmed in smart contracts. Blockchains like Bitcoin and Ethereum do not have access to information outside of the chain, off-chain, which means there is no direct way to verify the conditions the smart contracts are based on. So an oracle provides connection between a blockchain, which is referred to as on-chain, and the external off-chain world. They serve as the bridge between the blockchain network and the outside world. An oracle triggers the execution of smart contracts. So this is significant because more and more smart contracts need information or outside services to execute the smart contract. For the contracts to have the right output, they must have a reliable way to verify that input. And we can talk about a handful of examples of why smart contracts are actually needing, these outside services and connections with data off-chain. So oracles can interact with external software as well as hardware. Software oracles are connected to the internet and can both supply information to smart contracts and send that information in real time. This really makes them one of the most common types of blockchain oracles, and the demo that we're going to be looking at today is going to be using a software oracle. We're actually going to be using an API to make a GET request and then get real-time information back about the price of Ethereum. Hardware oracles are designed to get information from the physical world and make it available to smart contracts. So that's a little bit about the difference between those. I'll share examples in just a moment. An oracle is not a store of the data or the data source itself, but it is a layer on a separate network that can query and verify external information before it gets passed back to the smart contract in the blockchain. So to call data from the outside world, the smart contract has to be invoked and a network resources has to be spent. So on Ethereum, we're going to be spending actual gas or some kind of token resources. Some oracles can also relay information to smart contracts, but send it back to external sources. So there is either inbound or outbound. Inbound is going to relay off-chain data from the external world back to the blockchain or smart contract. An example here, if we're looking at a hardware solution, might be an IoT thermometer that can monitor the heat inside of an ice cream delivery truck. It could be constantly looking for a safe temperature range that is decided upon in the smart contract that the temperature must stay below. So the smart contract will automatically execute payment to the delivery service as long as the truck temperature stays within the acceptable range. So this is kind of a common example that we might look at where we're using some kind of hardware solution. I think IoT solutions are generally some of the most popular solutions that have been explored, and kind of being able to read information directly from those and interact with our smart contracts and tell us information in real time. For outbound, we're relaying on-chain data from a blockchain or smart contract to the external world. So a good example here could be maybe you're checking into a hotel room, they receive your payment. A smart contract can then communicate with an outbound oracle to unlock the door, turn on the lights in the room, and so on. So here it's a little bit different because we're actually just using some kind of software. Typically, there's an API that you're calling that is kind of relaying this information. So let's talk about why they exist. So oracles are our connection between the digital world and the physical world. They are really the only way for smart contracts to interact with data outside of the blockchain. If you are familiar with smart contract development, you kind of know the boundaries that you work within, and being able to get any kind of external information. You really have to use these oracles to be able to both send and receive information off chain. Without oracles, smart contracts have much more limited application. Smart contracts really would only rely on information already within the networks, which again is pretty limiting of their capabilities. Oracles are a large part of the real-time data benefit of blockchain applications. By being able to supply smart contracts with the most up-to-date information has a huge advantage. And when they are used correctly, oracles become a key part of the scalability solution. So this can really help blockchain solutions be more adopted widely, and really, help us to kind of help maybe not help us, but help businesses to kind of be more comfortable and introducing blockchain solutions to their business, and being able to introduce these oracles and have a trustworthy data source that they can pull from and kind of really make the best and most optimal solutions. But there are a number of challenges. We should be able to trust the data from oracles, but can we actually? I think that's a big question that comes up. Since a big benefit of blockchains is security, it is vital that an oracle ensures trust and security for smart contracts. The data that they supply must always be provided in a safe and accurate way to not compromise the blockchain. So you have to make sure that the data source is well trusted and reliable, and that might require you to really look into the sources that you're using, be aware of their vulnerabilities, and what risk they might pose to your solution. It could really depend, but for example, if you're looking at the difference between a hardware and a software oracle, you might think that hardware solutions are a little bit more trustworthy. Software solutions are probably a bit more readily available and easier to integrate, but just having to be more aware again of the sources that you're using, and that they can be trusted and not compromised is a really big, important part of being able to use Oracle successfully. Due to the complexity of operations needed to verify or get multiple results for additional validity, it's frequently quite costly to use an oracle in production. Extra calls are made, which means more gas or tokens used per transaction. There's also just the time of kind of waiting to get or send data to an external source. So they do make solutions a little bit more costly, but at the same time, when used correctly, again, they should make your solutions much more valuable. There is an increased risk of centralization and attack surface. So you have to consider that when you're introducing an oracle, you are introducing more attack surface or surface area, from the blockchain to the connection with the oracle source that you're using to other APIs or software that is maybe introduced in the solution. There is just more that you're opening up your solution to be vulnerable in certain areas, and just more that you have to kind of test and check that you are kind of doing the right things in your solution. So those are some of the big challenges that are really faced when folks think about using oracles. So I think it really comes down to being aware that you are using a trusted source. You are kind of aware of the implications of maybe this being a bit more costly, and just really making sure that you are looking at ways that your solution can be more vulnerable and trying to combat that. So now let's get into a little bit about solutions. So I just listed a few different ones here. I'm not really going to get into them so much, but I do encourage y'all to go and check out some of the different solutions available for creating and using oracles. This is something that is actively being worked on by a number of companies here. This technology is still very much rapidly advancing. I would say Chainlink is kind of considered the current front runner and most mature out of all of these solutions. But there's still, room for improvement across the board with each of these solutions. And for today's demo, we are going to be using Chainlink. So I'll probably be going there and kind of looking through the documentation and just, showing you ways that I've explored using the solution. I think that their documentation is actually pretty good. Again, room for improvement, but what I've seen for kind of most of these solutions here, there is like tutorials and documentation and such that you can follow. And let me just hop over there now. We can start looking at maybe Chainlink is the one I'll focus on. But again, I do encourage you to check out these solutions and kind of what they have to offer and how it might be different or the same. So let me hop over to Edge and let's go ahead and just look at Chainlink. It was chain.link, I believe. Okay. So this is just their homepage. If you want to learn a little bit more about the solution, they have right off the bat some suggestions of how you can start building your universally connected smart contract. So price feeds is a really common example. We're going to be looking at a price feed example today of getting the latest price from an API. There is also some randomness examples that you can explore here, or just, for example, how you might be able to request and use data from any API. But yeah, this might be a place to start. I typically have spent time either mainly in the docs around getting started. I think these are pretty detailed. There's great stuff here, great tutorials for beginners, intermediates, developer references here for using price feeds. We'll dig into some of that later. So this was kind of some of the stuff that we saw on the homepage, just expanded a little bit more. But there are good tutorials here for getting started, as well as the developer sources, which I'm pretty sure just links you to pretty much the same place, if I'm not mistaken. Okay, so that's a weird thing, but yeah, this might be a great place to kind of come check out and start actually building from here. I will point out that maybe nothing else related to this, actually. We're going to be coming back to this, like I mentioned. I am probably just going to go ahead and jump right into the demo and get working with that. So if you all want to follow along, I would encourage you to do so. I'm going to be using Remix IDE, just the in-browser IDE, to go ahead and work with the contract there. I'm also going to be using the MetaMask wallet and kind of loading that up with some test Ether. We're going to be using the Kovan Test Network today. That's kind of one of the test networks that I work with most often. We're also going to be using the Chainlink API and the link token that you see here and kind of exploring with that. And I think that's about it. I mentioned we are going to be using the Kovan Test Network. So I'll go ahead and just drop a couple resources into the chat. That might be helpful. So I dropped the Chainlink docs that you see here into the chat, as well as this link to a GitHub Markdown page. And so this GitHub Markdown page is the introduction to Oracle. So I'm kind of roughly going through the information that is in this exercise here. And I want to focus down on the example contract. And what I would recommend for you all to do now is go ahead and copy this contract with me over to Remix. So in another tab, I'm going to open the Remix IDE at remix.ethereum.org. Remix is pretty sweet. I really enjoy using Remix. I'm either always using the Remix IDE or VS Code. I think both of them have their advantages. For example, here I already have this contract loaded into Remix. It's nice because it stays here, so it is kind of like you know, a nice file editor. I don't have to worry about like losing my work when I go away from here. And let me just kind of walk through some of the pieces of this contract as we're getting started. So hopefully y'all are following along as I am doing this. I start with the Solidity Pragma declaration. I'm just using a compiler version greater than 6.0, but less than 0.7.0. This is not the most up-to-date one. It might be a good idea to go ahead and update this at some point soon. Yeah, but I think my compiler by default kind of selected this version to use. Again, any version typically between 0.6.0 and less than 0.7.0 is going to be just fine here. I am importing the Chainlink Solidity file that I want to use. It might be helpful to go ahead and look at this and get a little bit more familiar with what's happening in the Solidity file. I will go through that in just a moment. Our contract is called API Consumer, and we are inheriting this Chainlink client that we imported just above here. Let me just close this, sorry. There we go. So I am defining some state variables here. We're going to have an Ethereum price. We are going to be able to have an event, log new alert. That's going to have some description that we pass in about whatever alert that we are going to be sending out. Then there are a few more variables for the Oracle, the job ID, and the fee. So these all really correspond, and we can maybe focus our attention next down on the constructor, where we are using Chainlink's Oracle address in the job ID. The job ID is kind of just defining like what it is that we're trying to achieve. So there are different job IDs that we can use. And I probably will jump around just a little bit. If I go to look at the, is it the link token contracts? I have to remember where it is, but those addresses are defined. They are going to be the same for you if you're using the same example, where they're not just random. I didn't just make these up. Where are those docs at that describe this? Okay, so using any API contract addresses are defined here. So there is this Oracle address, which corresponds to the same Oracle address that I was using here. And then there is the job ID. So there's this table of job IDs here. I am using this one here, but they're basically just kind of defining the actions essentially that I can do with this job ID. This section is actually really helpful about contract addresses. It's kind of defining, you know, per network, mainnet, and all the test nets, how you might go about using this Oracle. And kind of just explaining each request on the network is going to cost 0.1 link. It's going to wait for 3 confirmations before processing a request. And here's some addresses you can use. So that's basically all that I have defined in my constructor here. And then I'm calling this set public Chainlink token, which is using this method available in the Chainlink client. Something else that I think is helpful here, I will try to stay on the same page, but I do get excited going through this stuff and I might go on some tangents. So I was looking at the Chainlink market. So if you're, you know, maybe wondering still like what else you can exactly do with these oracles, what information that you might be trying to get, I think the market has some interesting information here about, you know, more about how you can use Chainlink. And there are actually some specific examples that I was seeing here. New nodes about, you know, what nodes can accomplish. So there is some kind of financial analytics and data platform, more finance related jobs, Chainlink node on mainnet, This one is interesting. It's an external adapter for connecting to sports data. So yeah, there's different jobs that you can look at here, different adapters, nodes, all kinds of things. But this might start to give you an idea of how you might use Chainlink, or just, Oracle solutions in general. There are just different kind of adapters and jobs that you can tap into. So that's all that I'll show there for now. So that's what our constructor is basically doing. Then we have just two functions. So there is a function to request the Ethereum price. And so basically what we're doing in here is building this request. So we're calling build Chainlink request. We pass in that job ID. We pass in an address and this. Then what we're doing is building this request. So all that we're doing here is we're using a very simple placeholder API. You can essentially just replace this with any other API that you want to try out. I can show you what this, the contents of this are. This is actually this JSON. It just has a user ID, an ID, a title, and just some random fields here essentially. Then what we're going to be doing is specifically looking for the ID, which was 12. Then we're going to be logging a new event, which will be request sent, waiting for response. So we'll be able to see that when we deploy and interact with this contract. And then we return a Chainlink request too. So we use that Oracle address, we use that request that we have created up here, and then we also pass in that fee, which is 0.1 link, which is the token of Chainlink. And then what we're going to do finally is fulfill. So this is the last function that we have here. This is using the record Chainlink fulfillment function. All this is essentially doing is emitting another event saying fulfill called. So this request was sent successfully, and then it's going to update the price here with the price that we got back from the request that was sent. So that's essentially what this is doing. It's a pretty basic contract. This was just an example I thought to start out with. If you go back over to Chainlink and you wanted to explore that more, there are more examples here. For example, in using price feeds, let me get the latest price. There are similar examples here. So using Solidity, this is pretty similar to the one that I'm using. There's also examples using JavaScript or Python, which is pretty cool if you want to think about different implementations in different languages. There's other examples for historical price data and so on. So there's some nice data here, nice information for you if you want to learn and explore more. But I think that's about all that I'll say for now. Let me just go ahead and run this example. If there are any questions, let me know. So I'm going to go ahead and compile. And if you're following along, you should see the same thing. There is one warning. It looks like, do I see that here? Am I suppressing the warnings? You don't really need to worry about this. You might just want to look at it to know what the warning is, but I'm not going to even fix it. It is not important. If it was an error, I would want to fix it, but it is just looking for the SPDX license identifier, which might be provided at the top of the file. Cool. I'm going to go ahead and deploy. So for this, I want to just kind of set up what I'm going to do to deploy. So I'm not going to use this JavaScript VM environment. I'm going to use the injected Web3 environment so I can connect with MetaMask. It kind of automatically picks up my MetaMask wallet, and this field here populated, this account field. So it just kind of goes ahead and picks the first account from my MetaMask. And that's what I want to stop on for now. I am going to open my MetaMask wallet. And let me open this in a new browser because you're not going to be able to see it, or a new tab. Expand view. Okay, so This is the same account that it picked up on in Remix IDE. I'm not necessarily showing how to connect to that. If you have a MetaMask account and you're signed in, typically you would want to make sure that you're pointed at the Kovan Test Network. And then essentially it should just recognize that since you're using Injected Web3, this is just going to be by default the first account that we're going to go ahead and use. If I were to switch accounts, it would pick up on that as well and update that here in Remix. Before I do deploy, since I am using Kovan Test Network, I would need to make sure that I have Kovan Ether. I do have some Kovan Ether already, but I do want to point out how you might go about getting more. And there are a couple different options for that. So there is, let me just open up these links here. There is the faucet.kovan.network, where I can log in with GitHub and then simply pass in the account address to here and request some Ether. It takes about a minute to get, but it's pretty quick. There is also this Getter chat. So this is also pretty nice to use. I think I use Getter a little bit most often. They give you, oh, it looks like they've been sending 6 Kovan Ether. Before, I think it was 4, and this is, I'm pretty sure, 1. So let me go ahead and post the link for this as well. So you can use any of these options. It's really up to you. I'm going to go ahead and use the Kovan Getter here. So I can sign in to start talking. I think I just sign in with GitHub, which works for me. We can go ahead and continue. Cool. So once I'm here, I can just go ahead and go back to MetaMask. I'm going to click on this to copy my address and then paste it back in here. And that should just, again, just take a minute. Someone will respond. I see the chat is pretty active in here from just a minute ago. I'm seeing messages. And then once that updates, once that goes through, I will see this update here. So you just, again, will need to make sure that you have some Ether, some test Ether before you go and actually do the deployment. I do have some, so I'm going to continue on with the deployment, but we will check back there just momentarily. So now that I'm here, let's go ahead and deploy. And what's happening that you can't see at the moment is that MetaMask has popped open my wallet, and they are just confirming the transaction that it's going to use a nominal amount of gas. So let me go ahead and confirm that. My gas fee is 0.0187. So you just should have a default amount set there. And so that should be deploying. I typically like to keep up the little terminal window here where I can be listening to what's happening. So I see that this transaction was successful here. I also now see that I have the deployed contract here. So this is my deployed contract address. I see the fulfill method, the request Ethereum price method, and then the Ethereum price kind of state variable that I'm working with. Cool. So let's go ahead and see. Oh, no one responded to my, oh, okay, cool. So I just got a message when I came over here. They sent 6 Ether to this address. So if I go back to my account, I see that that was updated. So this amount of test Ether will last me like quite a while, but it's just nice to have over time. It's nice that it just stays in your wallet and you're pretty good to go there. All right, so the next thing that I want to do is actually get some link. So the link is just kind of the token of Chainlink. So I'm using that to actually interact with the Chainlink Oracle. And there is a specific way to do that. So I'm going to go back over to Chainlink, and I think the link token contracts is what I want to focus on. So if I go down to the Kovan section, I see that there is the testnet link. Oh, sorry, that's for Rinkeby. So I want to look at this I just kind of looked at the faucet. I got more testnet ether there. I now want to get some chain link for Kovan, or some link for Kovan. All right, cool. So then what I want to do here is post in my testnet address. So notice that I have some testnet addresses from before. So after I've deployed the contract, how I can get my deployed contract testnet address is from here. So I can just press this little option here, copy value to clipboard, go back over to the chain link faucet and post that here. Confirm that you are not a robot. Select all mountains or hills. Oh geez. Oh geez. This? I don't know. Probably this. All right, and send me 100 test link. All right, you get a message, your request was successful. View your transaction here. So let's go ahead and view that transaction. This should take me to Etherscan. I really like Etherscan. This is just another good place to come and kind of confirm that your transaction was successful. This is also just helping to kind of reinforce how blockchain technology works and being able to see the transaction hash, the block that was generated, the number of confirmations, and just lots of other metadata. That is just kind of helpful to build your understanding of all this. And if I go back to Remix now, nothing has changed there, but what I want to do is actually now go back to MetaMask, and I want to I think add my token here. So I do already have some links, so let's go ahead and add token. We're gonna do a custom token, and here we want to put in the token contract address. So I don't know that offhand, but it was in the chain link documentation. So the contract address is this. That's defined here. We're also going to need the symbol in the decimals, which should just auto-populate for me. Oh, I've already used that. Oh, it's already been added. Okay, this is helpful. Maybe if you're doing this for the first time, this won't happen to you. I think because I have already added this token, I do already have chain link for this account. I can't just add more. I thought I could, but I would probably need to use a completely different account. So I think how I would do that, let's see if I switch to a different account here. Let's see, account 3. And I wanted to add a token here, a custom token. Link 18, so it does just kind of fill out the symbol and the decimals of precision by default, and I can click next. 0 link. Oh, okay. Let's see, if I go back here, and I'm back at MetaMask. I'm sorry, I'm back at Remix. So I had that account that I was using by default. That was my first account that I deployed the contract with. And then it had this deployed contract testnet address. So I used this address, which I think was tied to this account. So I would essentially need to do all that over again. So I'm going to go back to account 1, but I think if you're doing this for the first time, you shouldn't have those problems. But if you need to retrace your steps, that's okay. So here I have 70 link. You can see that I've done this a few times, but what I would want to do is send a certain amount of link to my particular contract address. So what I'm going to look for now is back in Remix. I need to use this particular contract address again. I can search for that. I want to send 10 link over to this contract address. Okay, and I'm just going to say next and confirm. All right, and let's just wait for this to actually be sent. It's pending currently. It's still pending. All right, so we have sent link now. We've sent 10 link. that is associated with this particular deployed contract. So now I should actually be able to effectively interact with this contract. So there are just a few things that I wanted to demonstrate here. I'm going to make that a slightly bit bigger. I'm going to select Ethereum price here, which is currently 0 to begin with. I should see that this call happened here. Just called the Ethereum price. Not function, I just called that state variable to learn the value. Then I'm going to go ahead and select request Ethereum price. I see that the transaction is now pending. My MetaMask wallet pops up with a notification to confirm this transaction. So let's go ahead and do that. It will be pending here. I get this Kovan Etherscan message here. I also get the confirmation right below. Again, I pretty much always will check out the Kovan Etherscan transaction just to kind of confirm what's happening over here. It is still pending on this end. Cool. I think I just needed to confirm. They needed 3 block confirmations for this to be successful, as the documentation was saying. So that is now successful. I could see that it was from this address to this contract, which corresponds to what I'm using in MetaMask. Yours will be slightly different. And I go back to Remix now. I do see that my confirmation was successful. Just more information here. You could scroll through this and just kind of look at what's happening. I know that I do have an alert that was sent out from calling that event. So I might see that some of that here. Anyway, what I should be able to do now that I have requested this price from after sending out this GET request to this JSON, if I now select Ethereum price, what happened was the price updated. It was previously 0, now it's 12. So it just kind of got that idea of 12 that we had here in this JSON that we got from sending that request. So that is kind of the basics of being able to actually use oracles and kind of use any API. Again, you can kind of replace this with anything that you want. Something much more interesting, not kind of some random JSON, to get helpful information back to you in your contract. So I think that's all that I wanted to show here. I'm curious. I hope that worked out for you folks as it did for me. I think, next steps for this would be kind of exploring, some more of these examples, perhaps getting more of an idea of what you would want to replace actually. So you could always feel free to come back to any of these and look at different ways that you can use other Chainlink Oracle solutions. You can switch out the API here to do something a little bit more interesting and get other data that might be relevant to you. But this is kind of the basics of how you would use a generic GET request to get information back into your contract. So yeah, that's essentially what I wanted to go over today. If you do check out the markdown that kind of has this example, this might be a good place to refer back to as well. If some of that didn't make sense, you can kind of walk through the same steps that I went through here. But yeah, those are kind of the big takeaways that I wanted to stress from this demo. I'll wait to see if anything comes up. All right, so just to reiterate one more time, I think that this shows kind of how easy it can be to be able to integrate with these oracles. So Chainlink as an example, if you were to use any of the other solutions that I had suggested, like Provable or Band Protocol, you can see that the process is somewhat similar to be able to kind of use one of their contracts, integrate with their Oracle using a specific address, some job ID, and kind of generating the request that you want to send. I think it's most straightforward to kind of use the software examples like we looked at here, with being able to look at how you can just kind of like send REST data, send and get REST data. So sorry, I did lose my train of thought, I will admit, but those software examples of oracles are kind of the most straightforward to use. With hardware, it is going to be a little bit more involved to kind of figure out how to use and kind of connect a solution with. And I don't know, actually thinking more about it, I don't know if Chainlink is kind of built out to help you do that really well. I'm going back to my browser and looking at, because I've pretty much only used some of like thinking about the hardware or thinking about the software solutions. I don't know exactly how it might be suited well for a hardware solution. And that is just more involved. For that, of course, you probably need more to get started out with. You need some kind of hardware device that you want to integrate your solution with. All right, let me take a couple questions now. A rather wide-scoped question, but briefly, what is the current Microsoft blockchain offering? Yes, that is a good question. Let me head over to, maybe I don't have a slide for this. I do want to look at the Azure blockchain offerings. If I go to Azure and I just look at blockchain, this is going to be the best place for me to get a little bit of a better idea of the blockchain offerings that we provide at Microsoft. So there is the Azure Blockchain Service, the Azure Blockchain Workbench. Those are kind of the big solutions that we offer. Azure Blockchain Service is really great at kind of helping you manage your consortium or private blockchain networks. So it's easy there to kind of manage membership of your consortium. So you can kind of invite people to participate in your blockchain network, give them certain permissions. There is great monitoring tools there, so you can get a lot of data about what's actually happening on your network. The activity, how many transactions are happening, the number of blocks. You can get a lot of good insight there. You can also integrate with tools like Azure Logic Apps or Azure Cosmos DB for Azure Blockchain Service, which will allow you to kind of put together workflows essentially to maybe be able to get data from your blockchain network and possibly like put it in Azure Cosmos DB. That's a common solution that I see there. So being able to kind of like store your data there. So being able to take your on-chain data and put it somewhere off-chain, that's kind of relevant to what we were talking about today. Azure Blockchain Workbench is a great place to prototype your apps in the cloud. So this can be a good place if you want to actually see your smart contract solutions come to life. You can kind of put apps together where you can be able to interact. So for example, what we were looking at, if we wanted to request price, request the latest Ethereum price or something, we can kind of like build an app, putting some building blocks together and being able to like have an interface to just easily like press a button and call that function, as opposed to kind of having to do that in an IDE more through the code than kind of user interface. So that's an example of what you can do in Azure Blockchain Workbench. There is also the Azure Blockchain Development Kit, which is a extension in VS Code. I'm a big fan of that extension. So what you can do in that extension, if you haven't seen it, it's really helpful to help you. It's really helpful for creating new blockchain projects and doing things like compiling and deploying and just interacting with them locally, kind of on your development network before pushing out to Azure Blockchain Service, for example. So those are the big solutions that are currently available. Let me know if you have any other questions around that. I don't know if that was brief, but I tried my best. Would this work on the XDAI chain? I'm not completely familiar. XDAI chain. Let's take a look. Okay, so this is a stable payments blockchain for fast and inexpensive stable transactions. Yeah, I'm not completely sure. I imagine it might. We might want to look at some of the developer workflows and kind of understand how to use the XDAI chain. I don't know why it wouldn't necessarily work on the XDAI chain. I'm just less familiar. Oh, hold on. Maybe I should read more. But any contract that works on the Ethereum mainnet can easily be redeployed to the XDAI chain. Okay, then that's comforting. It seems like then it would, since the underlying architecture mirrors Ethereum 1.0, meaning that smart contracts can be written and deployed in the same way using a different RPC endpoint. So it sounds like something similar like this would work for this chain as well. And yeah, I don't necessarily see why it wouldn't. I don't know exactly what smart contracts look like here. Maybe it's very similar to how, if you can use Solidity to write smart contracts, then it might be very, very similar to, again, being able to use kind of a different RPC endpoint to deploy and kind of use Oracle solutions there. So yeah, I think it would, again, I'm not completely sure. I feel like this is something that is worth looking into more. Wallets, you still can use MetaMask. Yeah, it seems like much of this would be pretty similar, just using a different chain here. But yeah, you should be able to still follow the same process using some kind of test net, some kind of provider like Chainlink, for example. Do you know a good place to refresh yourself on basic blockchain fundamentals? So there are a lot of places. I think something that I kind of find myself coming back to is the Ethereum website. They typically have a lot of good resources. It's kind of specifically for Ethereum. About kind of getting started here. There are some great kind of learning resources. Which, yeah, is just particular maybe to Ethereum, whereas you want blockchain in particular. I have to think more about those resources. There's also a learning path on Microsoft Learn that I would recommend. Let me go ahead and get the link for that. Is getting started with blockchain development. This might be kind of a good place to get started with. There is a number of modules in this learning path, starting kind of with an introduction to blockchain. What is blockchain? How blockchain works? Blockchain types. So this would be a great place to start, completely from the beginning, by being able to kind of build up your knowledge on how you can actually get started with development. On Ethereum, for example, this could be another great place to come to. And the next question is about examples of some real use cases of Chainlink. So I had called out a couple, and Chainlink calls out a couple too. I think the big ones are using price feeds, especially for some kind of financial data and just seriously simply being able to kind of get the latest prices of Ethereum, some currencies, any kind of stocks. That could be a really popular option is literally just pricing data. Using some randomness. I don't know. I don't really know what some kind of these examples were. And looking more through this, I don't really know. Yeah, maybe this is not a good realistic use case because it is literally just getting randomness. So I'm not sure if that's what you would want to use it for. There was also the market that I was looking at. Where did that link go? Which I think that there were some good examples in there. There were a lot of financial specific kind of jobs that you might be working with. There was also one about getting sports data. I don't know where that went. Contract addresses. Yeah, I don't know where that went. There was like the marketplace in here though that I had shared earlier, which I think has some good examples in there. I will find where that was. The Chainlink market. Let me get the address for this, the link for that, and post it in the chat. But this I think has some good examples of what you might be wanting to do more realistically with Chainlink. So there are just examples of different nodes that you can use here and interact with in your contract. Again, most of them were kind of financial related. There was this one about sports data. I don't know what other adapters and jobs they might have, but that could be helpful to look through as well. This one is tracking COVID data. True USD. So yeah, lots of currency related things, which yeah, there's a lot more than you can do with that. But I mean, the examples are pretty wide. I think these are just good ones to get started with. For your solution, you might have something like more realistic that you actually need to get outside data from. I think earlier I had given an example about like checking into a hotel, getting, off-chain data relayed back to be able to like unlock your room and do interesting things there. So there's a lot more like real world examples that you can look at of what you actually want to do with that data, or what you actually want to be able to do after getting something from off-chain. And then there's another question about how would you go about implementing oracles on layer 2 solutions like XDAI chain, for example. So let's go back there. Where can I find an example of like what a contract looks like on XDAI chain? Because that would be helpful. Use cases, projects, and dApps, maybe. And I do see here there is a partnership with Chainlink. Maybe let's check that out. You have to do some exploration. Like most of this, you're like exploring and thinking about what you want to do, and maybe you can find some example tutorial, follow that, implement it, and then start to get a better idea. I can stop scrolling for a minute and read through this, but Protofire. This is a recipient of the Blockchain Integration Grant as part of the Chainlink Community Grant Program. Protofire is a provider of development services around blockchain. Maybe that's something to look at that's interesting. Protofire. Okay, so what we do: smart contract development, assessment of architecture, complete dApp development, dApp developer tools, and they do have integrations with trusted feeds. So this is generally explaining what they do. It seems like this is a possible solution that you can use to help with your smart contract development, dApp building, integration with Oracle. So kind of your complete blockchain solution provider. I'm sure this is a paid tool. So seems like it could be something good to use. Like if you come to them with an idea, I don't know how much you would actually be doing on your own here. So maybe that's not what we want to be looking at. But that's the vibe that I'm getting, is that this is actually some kind of paid tool. I myself, especially with learning and trying to get more familiar around development with this stuff, I really try to look at free tools that I can use. But if you do have a solid idea, this could be something that you want to explore later. So back at XDAI chain, projects and dApps, maybe that's not what I want to look at then. Use cases. Let's just pick one of these, maybe prediction markets. What I'm really looking for is like how to like actually use XDAI chain. All of these use cases and projects are helpful, but if there's developer resources, stable. Let's start here maybe. So yeah, you probably need to look around here, being completely honest, because I don't know off the bat. It seems like from what investigation we've done and can see, you can use XDAI chain. It's kind of built off of Ethereum 1.0, so I imagine much of the development for Ethereum is pretty similar as it would be an XDAI chain. For other layer 2 solutions, I'm not sure. You really kind of have to get down into their development resources and start to understand what you can do from there, and just how you get started with like, how do I build a smart contract? How can I integrate with these features, with these additional solutions, these third-party solutions? And that's kind of what I'm going down the hole of looking for. Okay, and this is really what I wanted to see, is like, what does the contract look like? And maybe from what I can tell, it's like not necessarily any different at all than like, you know, what we just saw with the contract that I was writing here. It looks like it's still using Solidity, so that's an option. There might be other languages that you can use, I'm not sure. But it looks like the contracts themselves might actually look very, very similar from just looking at this one example. So yeah, I imagine they would almost look pretty similar. It might just be about how you're actually like kind of connecting two different networks and what the kind of deployment process looks like, perhaps. Smart contract deployment. So yeah, okay. The XDAI chain is EVM based, so the steps are the same as deployment to Ethereum, POA network, and other chains. So there is this RPC, there's a specific network ID. So I mean, from what I can tell, it's actually going to be pretty similar. And following some tutorials like this about how you're actually like developing, compiling, deploying would be the most helpful. Oh, there's a remix tutorial, sweet. Yeah, something like this following through I think would be super helpful, probably the most helpful. This tutorial is a little out of date, a couple years old, but you might want to start here. Anyway, I hope that helps. I'm kind of rambling a little bit. I do want to say thank you. I think hopefully y'all can kind of go forward and explore some of this on your own. If you do want to reach out, please do. I have my contact information here. You can reach me on Twitter, on LinkedIn, or via email if you want to talk any more about oracles, go over any examples. I'd be happy to chat. You can let me know. I'd also really appreciate it if y'all could fill out a brief survey about this stream at aka.ms/reactor/survey. The event code is 12961. And I just want to thank you all again for joining me today. Have a great day wherever you are in the world and take care.